Who lives in a pineapple under the sea? 6.2, multiplying and dividing. Oh, we're going back to the basics. But we're not just multiplying and dividing numbers, we're multiplying and dividing radicals. All right, so you can only multiply and divide radicals if the radicals have the same roots to them. Radicals can only be combined if the roots match up. So for example, if we look at these two expressions, we have fifth root and fifth root. They both have a fifth root in them. So when that's the case, you can combine them, make them one giant fifth root. And then of course, multiply 8 times 4 is 32. And then maybe in your head you know, but if you don't know, you can always break it down. But the fifth root of 32 is 2. All right. Let's see. Let's do another example. Notice these are both square roots. There's an imaginary 2 there. So they're both square roots. So when they're both the same root, you can combine them. All right, so the way I combined them, I skipped a step, but I took 72 times 10, and then x to the third power times x to the first power is x to the fourth power. And then y squared times y to the third is y to the fifth power. And from here, you break it down. Use your factor tree to break it down and simplify. And that's what we have. 720, when you break it down, is 12 square root of 5. And then, of course, x to the fourth, if you look for pairs, there's 2 pairs of x to the fourth. And that's what happened. And then if you look pairs for the y's, there's 2 pairs for the y's, so that's why that's y squared. And then there's 1 left over. Okay, and we did simplifying last section, so that is a little bit of a review for simplifying as well, but that is our answer. And then our third example. Notice this is the third root and this is the fifth root. When they're different roots, you cannot combine them. There's a different way to simplify, but this lesson talks about combining the same roots, and in this case you cannot combine them, so we will leave those alone. We can't simplify that. All right, how about dividing? Same thing, radicals can only be combined if their roots match up. So this one, the numerator has a third root. The denominator also has a third root, or cube root. So when they have the same root, you can write them as one giant cube root. And then from there you can simplify. You can go ahead and do 162 divided by 3. That gives us 54. And then y to the fifth over y to the second. Remember, there's a rule where you subtract the exponents, so it ends up to be y to the third power. And then from here, you have to break it down. But again, that was last section, so I broke it down for you. We have the 54 breaks down to a 3 radical 2. Okay, and then the y to the third power, you have to find triplets, and there's only one triplet. So I pulled out a y. Now it looks like it says y to the third, but it's not y to the third. There's just one y. The little 3 there means the cubed root. It's these little 3s. They look like they're part of the problem, but or part of the answer, but it's part of the root. Okay, so there we have it. 3y cubed root of 2. All right, let's focus on some denominators. There are 3 things that cannot be in the denominator mathematically. You guys learned back in middle school that you can't have a 0 in the denominator. I also told you that you can't have imaginary numbers, so you can't have an I in the denominator. We remember we rationalized it by multiplying the top and the bottom by the conjugate of the bottom. And now the third thing we can't have in the denominator is radical signs. All right, so this next part I'm going to teach you how to rationalize it so that the denominator does not have any radical signs in it. All right, so if you notice in this expression, there is a radical 2 in the denominator. Okay, to rationalize, all you have to do is multiply the top and the bottom by the bottom. There it is. So notice the bottom is radical 2, so I'm going to multiply both the top and the bottom by that. And the reason why we're allowed to do that is you are allowed to multiply any expression with a number 1, and the expression will be the same. You can multiply anything by 1 and it doesn't change the expression. And this is just a fancy way of writing 1. Anything over itself is 1. And I chose this fancy way of writing 1 because look at what happens. When I multiply it across the board, I have radical 10x over radical 4. And guess what happens to the radical 4? We can simplify it to get radical 10x over 2. And that's why this part works, is because it'll always make it come out perfectly. All right, so that's how you rationalize it. Let's do one last one for the day. Notice we have a cubed root of 5. All right, so it's a cubed root of 5. We're going to have to multiply it not only once, but we have to do it twice, just so that there's 3 of them. Cubed root, there's 3 of them, so that I'll show you what happens in a little bit. But yes, you have to do it twice. And if you multiply it across, the 20 times the 5 times the 5 is 100 x squared. And then the bottom, the 5 is 125. And guess what? The 125, when you cube root it, it's just 5. All right, so that's it. That's multiplying and dividing radicals, and then rationalizing them when you have a radical in the denominator. All right, go ahead and try your homework.